Okay, good morning, everyone. You're welcome to week 4. Yes, last week we started with, you're welcome to week 4 of software evolution. Last week we had a lot of software evolution, part of it, one, and that's Lehman's law. And this week we're going to look at the same law of software evolution, but we're going to look at it from another point dimension. And these are the different categories of the law, different systems, how this law can be categorized based on variety of system, types of system, according to layman. So for that reason, we have the following learning outcome. Please confirm you can see my screen very well. Is it visible? And the font, are they okay?
Yes, it's visible.
Okay, and the fonts are okay. Are the fonts okay? Are they readable?
Yes.
Okay, great. So here are the learning outcome. By the end of the class, you should be able to explain the meaning of S-type law, P-type law, E-type law, these various systems as described by Lehman. You should also be able to differentiate among the three types with practical examples with both Uganda and global technology. And we should also be able to analyze why E-type system dominates in today's world and how they connect to Lehman's law of evolution. And then, fourthly, you should be able to apply this framework to understand evolution to the project in Ripen. Yes, to host 2 projects in Ripen. Some of you might be part of that. That's for artificial intelligence class. That's where Kamika should be part of that class that is doing this project particularly. And you should also be able to critically evaluate whether a system could shift from one type to another over time. So, introduction, and why are systems classified? The systems are classified according to Lehman because not all software behave the same. Every software that is in the market does not behave the same way. Some programs are like calculators in the sense that they are fixed, they are not changing, and they are provably correct. They have standard. Once you add X, you must have Y as the input, as outputs. As long as you are using X1, you must have Y1 as the output. So such systems are static, they are not dynamic. While others are problem solvers, they deal with uncertainty and can only offer good enough answers. Their answers are not definite, but they will give us answers that have very high probability. We are talking about softwares. We are talking about products in the markets. Yet others are like living cities. They are living cities. They're always growing, they're always adapting and reshaping themselves in order to survive. Lehman therefore introduced these classifications to help us understand software and its natural habitats in such that, and these are the classification, the S-type. The S-type means specification type system. It is rule-based and it is static. We shall see it in clearer details as we move on. Then you have the P type, the problem solving these systems. They are exploratory, they are heuristic. Heuristic is when you are searching for solution based on knowledge or understanding. You are not searching blindly, and their answers are approximated. Then you have the E-type. The E-type are evolutionary systems, which are the latest modern systems. These type of systems are tied to real world, and we say they are evolving continuously. Sorry. So let's jump on to S-type system, which is specification type. It is defined by the system itself. This type of applications are defined by mathematical or logical specification. A system that is correct if implementation matches the specification. The input is correct. The output is correct as long as the input matches what is specified according to the program, the design, the structure of that application or product. And this type of system rarely changes unless the rule, the internal rule themselves change. So let's look at global example. What are examples of such system? Number one, have you heard of sorting algorithms? Quick sort, merge sort. These are programs that are static. They don't change. The application that are static, they don't change. Compilers passing code against a fixed grammar. You've heard about compiler construction. When the compilers are passing codes, as long as they are using, you are passing the correct input, the output must be the same. A task calculation formula that is defined and stable. You have the task calculation where the formula, when you are using it, it will help to calculate a product or an application that helps you to automatically calculate tasks. So the answer, the input and the output are defined. As long as it is stable, then it belongs to this category. They don't change. Let's look at example from Uganda point of view. You can see our university grading formula. You build an application around this such that 70% plus is equal to A, 60 to 69% is equal to B, and the like of it. So this type of system are referred to as what? They are S-type system. A fixed electricity tariff or a fixed electricity tariff calculation like the Umome meter, they provide the tariff rules and remain unchanged. So nothing changes there. So what are the key takeaways in terms of the SPS type system? They are mostly stable and easiest to maintain. They do not evolve much because their logic is not dependent on changing realities. So as it is from the beginning, so shall it be until you are able to manage or you're able to influence the logic of that system. So let's look at the second type, the P-type system. The P-type system are referred to as problem-solving system. So the systems are built to find solutions where requirements are incomplete or uncertain. They use heuristic, like I mentioned. I've told you what heuristic means. Heuristic is when you are using knowledge to search for a solution. Let me give you an example. If you're looking for your phone, the first thing that comes to your mind where to search for it is, where last did I go to? Where last did I use it? When last did I use it? Under what condition did I use it? Oh, I used it when I was having my bath, or when I was in the kitchen. I'll probably go there first. So you are going to search for your phone based on your heuristic, based on your knowledge about where you use it last. So you are searching for the problem based on knowledge. So you should have a clue of where you are starting from. So we said that this type of problem-solving system, they belong to, okay, they use this heuristic. You can build models around them, and the answers are approximated. They are probability. So when you are building a machine learning algorithm that has probability, of course, the answers are the answers are presented in terms of a high accuracy, performance. So they are not static. If you run that algorithm several times, you may get different results. So the correctness in question, the correctness of that system is measured in terms of usefulness or correctness or accuracy. It is not by perfection. So let's look at this from global point of view. I don't know if you've heard about just plain AI like Alpha Zero. That's the typical example. As it is, that is how it is. Weather forecasting software. The weather forecasting software where it takes inputs from the various weather conditions and is able to surpass or forecast the current weather. So that is a typical example of a P-type system. Also a recommendation engine on Netflix or Amazon. You know what a recommendation engine means? Each time you watch a movie, if you watch a movie for the first time in Netflix, the second time you log in to your Netflix account, they're going to present to you various movies that are related to that previous one you watched. It is referred to as recommendation engine. It is a kind of machine learning algorithm or methodology that is used to build that. So Netflix uses it, Amazon uses it, even Google is using it now. So let's look at it from Uganda point of view. A tariff prediction model for Kampala, which uses data but cannot guarantee its accuracy. A machine learning model that predicts student dropouts. Any of you can decide to do this as a final year project. Machine learning model that could predict student dropout at Cavendish University. So what are the key takeaway, or what is specifically the key takeaway for P-type system? The P-type system evolve through improvements, not correctness, because you cannot say that this system is correct, but it can be, if they can be improved. They get better as more data and computing powers become available. Such are typical example or characteristics of a P-type system. So let's look at the third type of system, which is the evolutionary system. The evolutionary system is a system that evolves, and that's the current technologies we find ourselves now. We said a system embedded in real worlds, they must evolve continually. Call them either embedding system or evolutionary system or evolutionary type. They must evolve continuously to reflect regulation, users' need, competition, and economical or technological changes. Subject to Lemann's law of software evolution, it is called continuing change or increasing complexity. Remember, we had the different types of software evolution, law of con con continuing change, law of increasing complexity, and other laws. So this is a typical example of law of continuing change and increasing complexity. The typical examples of such systems globally are Google Maps. They are always changing. They must evolve with new routes, with new business needs, and user feedback. Another example is Facebook. You and I use Facebook, and it is constantly updating privacy settings, features, and the algorithms. You're using WhatsApp, you just see an update telling you to, sometimes it will request for your input depending on your setting. What about a local example in Uganda? The Uganda Revenue Authority e-tax system is also a typical example. It evolves as task laws and compliance framework changes. So once the compliance framework changes, it will evolve. The MTN Momo, it evolves with fraud prevention. These are typical challenges, societal needs, and international remittance. And due to competition, you have other service providers like okay, in Nigeria you have the Global.com, and you also have the Airtel. So because of these competitors and those that might even evolve in future, they are always trying to improve their system. You can also look at Safe Border as a typical example because they expand from support. Formerly, the Safe Border is just for transport. They move people from one place to another. But now they can deliver food, right? They can deliver parcel. They even include a payment system, that's the e-wallet payment system. These are some of the technologies that contribute to the evolution of these systems. So let's look at it from those 2 points of view. The host two, we say that these systems are living systems. The host two, like I told you last week, is a system that is evolving. It started from a normal website that could help synchronize calendar, smart logs, basic messaging for guests that uses the tool. Then it's evolved into a chatbot assistant that could easily look at, okay, you know what a chatbot is? That could help the user interact with the system itself automatically and answer basic questions, and also drafts the user's review. And now they are trying to evolve to a stage where it will auto respond contextually in real time to users' booking or to users' queries. Okay, yeah. Okay, that is what is happening now. Then that is the present stage of the software. Now they want to evolve this software to move it more higher, to build an agent around it that could help in confidence scoring, sentiment dictation, actionable issue discussion, dictation, reservation changes. These are the new demand, the new societal need that they want to meet up with in terms of this host tool application. And in future, they are looking at a multi-language support, a kind of predictive analytics, a type of integration with voice assistance. So based on this, you have this software evolving at every point in time. So what are the key takeaways? Based on the host tool, we can say that the host tool cannot remain static. It did not remain static and will not remain static because customers' needs, the booking platform, and regulation keeps changing. So we say that this system is what belong to evolutionary type of software. So here is a comparative analysis or summary of all we have been discussing: the type, the definition, the correctness, the global example, Uganda example, and how does these different types apply to the present software we are building at the moment. So it's a summary of it all. Why is this classification important? It's important to us. Why are we studying it as a topic? Because as developers, as we find ourselves as developers, it will shape how we design, it will shape how we test, and it will also shape the way we maintain the systems. And it's also very important, this classification are very important to managers because it signals whether a system requires long-term evolution budgets, such as the E-type. So when you're building the software, you know that you have to budget for it in terms of the evolutions that will be required in the future for that product. You also, if that system belongs to the S type, then you know that it requires minimum maintenance costs, and that will also affect your budgeting and planning. So for a student, it highlights that most real-world projects you will be working on, be it fintech, be it AI agent, be it education portals, belong to what? E-type evolution. So in conclusion, we can say that layman's classification shows us that software is not uniform. All software are not the same. The estimates are rule bound, they are stable, they have answers or solutions that are provable. The P-type systems are, I hope I'm still audible. Okay. The P-type systems are problem solvers that uses heuristic and they can be easily improved. You cannot say they are correct. You can only say they are improved. If you build a machine learning model that gives you 80% prediction accuracy, you can improve that same model to give you how many? 90% prediction accuracy. Another person comes up, does a research, say, oh, I can improve this model beyond that. So it belongs to the P type. And the last type, the E type systems are living, they are dynamic, they are changing, and they must evolve to remain useful in the markets. Okay, let's entertain your questions before we hop into the quiz. Yes, any question? Do we have any question, class? I'm sharing with you the link. Remember, remember, I want you to keep in mind that all these quizzes I'm doing with you will count. Because on the day of recording, when something happens, I can just pull it up and said, okay, based on this challenge, I might decide to add scores to your grade because this guy is always doing my quiz and he's performing well and he's always in the class. So this quiz is more or less my attendance sheets. It's a confirmation of my attendance sheet. So please make sure you join always, whether you are getting it right or not, because this course is not very practical. The only way I can engage you and make sure you are committed to it, one of the ways, not the only way, sure, is by giving you quiz immediately after the class. So it's going to be a model for this course. Immediately after the class, we run a quiz. So please join. Do I have anyone joined yet? Let me see. Only one person is ready. Please join. Two persons have joined. I hope you can see my screen. Three persons, three players are here. Let me give 2 more minutes. 2 more minutes. Okay. 4 players. It appears your internet is unstable. Please, excuse me. Are we good to go? 3 players. Four. You're stable. Your internet is disturbing. Yeah, you can. Okay. Okay, we have 5. I think we are complete according to the number of persons in the call. Let me share the link in the class group. Good, we are good to go. Answer quickly to get more points. Which of the following best describes as S-type system? $15. You have 4 persons have responded. Everyone has voted. Let's see the correct answer. Boom. Now remember, the fastest finger gets it. Let's move. Who is the leaderboard? Boom. What? Okay, good, good. At least everyone is represented. No one scored 0. And we can see Trevor is leading. Okay, ready to go. 4 players ready. The 5th player, you join. Good, great. 5 players ready to go. Answer quickly to get more points. Which of these is an S-type system in Uganda? Mm, 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 mm. Everyone has voted. Was the correct answer? Boom. E. Yes, is this an S-type system? Exam grading? Yeah. So let's see who is the leaderboard. Ivan is taking the lead. Boom. Boom. Travel. Sit up. Joseph, please. I want you to sit up. Don't remain there. Mohammed, Dennis, good. Good to go. Take it in good faith. 5 players ready to go. Move. Answer quickly to get more points. A P-type system is best defined as a system that must evolve based on social regularity, a system that finds good enough solution, very simple, but the fastest finger got it. Good. Pay attention. Okay, let's see. The correct answer is a system that finds good enough solution using heuristic. I emphasize on this several times. A system that remains unchanged over time is the S-type system. A system whose correctness can be mathematically proven is also an S-type system. A system that must evolve with social regulatory system, it is E-type system. So the correct answer is B. Who is the leaderboard? Mohammed is coming up, taking the second position. Boom. Ivan is still leading with 2,356 points. Lumbe, Joseph, wake up. Dennis, please wake up. Let's move. Question 4 out of 7. We're just trying to test our knowledge and how much attention we are paying when the course is going on. Ready to play 5 players? Answer quickly to get more points. Which of this is the following? Is a P-type system? Everyone has voted. Let's see the correct answer. Boom. Just playing AI. Great. MTN Momo Mobile is a typical example of E-type system, not P-type system. Okay, let's see who is leading. Boom. Dennis is coming up. Whoosh. Mohammed is number 2. Interesting. Ivan is still leading. Joseph, get it now. You must move from this position and you must add to your score. So let's move. 4 players ready to go. Number 5 player, please join. Yes, don't give up. Question number 5. What makes each type system unique? Very simple, but the fastest finger gets it. Boom. Yeah, E-type system does not use heuristic search. It is the P-type that uses heuristic search, the problem solving, where you can build model. So it must continuously evolve. Also, let's see who's the fastest finger. Okay, everyone. Who fastest remain Ivan. Ooh, Trevor has moved up. That's interesting. Yes, Lumba has come up. encouraging. It cannot be zero. At least you have come up. That's good. That's good. Mohammed, strive further to surpass Ivan. Let's move. Question number 6. 4 players. Number 5 player, please join. Good. We're moving right now, ready to go. Answer quickly to get more points. Which of these Uganda system is an P-type system? Remember electricity tariff, you are a platform, quicksolve algorithm, GCD computation tools. Let's see. Boom. The calculator belongs to the, remember, calculator tariff belongs to the S type because it must give you the answer, a provable answer. The quick sorts is a typical of P-type algorithm, and the computational tool is a typical of S-type algorithm. So the answer is Uganda, the class 16. Okay, let's see who is the leaderboard here. Good, Joseph is coming now. David, don't remain there. Oh, this is interesting and competitive. It's like E-type evolution. Now, but this guy, Ivan, is still remaining on the top. Mohammed, pick up. Trevor, you can do it. Lumba Joseph, you can do it. And Dennis, wake up. Okay. 4 players ready to go. The 5th one have joined. 1, 2, 3, go. Boom. The host 2 project evolving from chatbots as defined as, this is the simplest of them all, but the fastest finger. Fastest finger. Everyone have answered. Your network should not be. We're saying S type. Are you paying attention, or you click something else and your system gave you another answer? Let's see who is the leaderboard. Ooh, Trevor is coming. Eee, this is interesting, Trevor. So it's time for you to chase Ivan. Dennis, wake up. Yes, 8 questions out of 10. 1 player, please join to make us 5 players ready to go. Player number 5, join. Where are you? Where are you? Where are you? Are you having network issues? Good. Welcome. We missed you. So let's move. The host to sentiment analysis feature, dictating if a guest is upset, is an example of fastest finger. This is very okay. Okay. But it's not. Okay, let's see who fastest finger. Ivan is still leading. Oh, good. Interesting. Let's move. 5 player ready to go. Let's see the 5th player. Please join. Your network seems to be unstable. So let's move. Why do modern apps fall under E-type? Fastest finger. Good. They do not require user feedback. Who is saying that? Please check well. Okay, they must evolve continuously to reflect real world changes. Fastest finger is still Ivan. Dennis, wake up, wake up, wake up, wake up. We are in number 5. Oh, sorry, the last question. And we are good to go. Player number 5, please join. I think your network is a challenge. Okay, question number last. Which of these following pair is correctly matched? S-type Google Map, B-type Chase AI, E-type sorting and grading, P-type exam grading. Whoosh. B is the answer. Let's see. Yes, P-type is a typical example of, okay, sorry, Chess AI is a typical example of P-type algorithm. Sorting algorithm belongs to S-type. Exam grading is X-type. Google Map is E-type. So the answer is A. What? What? Wow. Ivan, congratulations. You are the leaderboard. This is good. Followed by Mohammed. You see, Mohammed from the down came up. Trevor was number 1 at first. Now you are number 4. Oh, good to hear that Joseph woke up and now he's number 3. And we have Trevor number 4. And we have Dennis number 5. And he was not the least because he was not zero score. So thank you, everyone. That's a good morning tease for you, a good morning quiz. Congratulations, Ivan. Please, let's give you a round of applause. Ivan, congratulations. You took the leaderboard today. Next week, let's see who will take the leaderboard. Thank you, everyone, and do have a good morning and a great day.